Hello, Stat 200, and welcome to Lesson 6. This is the first of two lessons on the topic of confidence intervals. Last week, you learned how to construct a sampling distribution when population parameters were known. This week, you're going to learn how to construct sampling distributions when population parameters are not available. In other words, in cases where you only have sample statistics or sample data. Let's start by reviewing what you learned about confidence intervals last week. This is the general form of a confidence interval. The point estimates that we're going to be using in this lesson are the sample proportion and the sample mean. Last week, you learned that if the sampling distribution is normal, you can apply the empirical rule. The most common confidence interval is the 95% confidence interval. When constructing a 95% confidence interval, you'll use a multiplier of 2, because approximately 95% of observations will fall within 2 standard deviations of the mean on a normal distribution. The standard error is the standard deviation of the sampling distribution. You're going to be learning bootstrapping methods this week. Bootstrapping is one method of constructing a sampling distribution using sample data. Bootstrapping is a procedure that uses data from one sample to generate a sampling distribution. This is done by repeatedly taking random samples from the known sample with replacement. We're going to do this first using stat key simulations. These are the key topics that you'll see this week. First, we'll use stat key to construct a bootstrap sampling distribution. We'll use the standard error method and the percentile method to construct a confidence interval using that bootstrap sampling distribution. Then, at the end of this lesson, you'll learn how to construct a bootstrap confidence interval in Minitab Express. You'll see that the standard error method is similar to the procedures that you learned last week. The preferred method is the percentile method. This is also the method that is used by Minitab Express. We'll start by looking at the standard error method, though. Recall the general form of a 95% confidence interval. The point estimate, which is your sample statistic, plus or minus 2 times the standard error. We can use stat key to construct a bootstrap sampling distribution to get that point estimate and standard error. Let's go to stat key. In stat key, we're going to bootstrap a confidence interval for a single mean. There are a number of data sets built into stat key, but I want to demonstrate this first using a very small sample set. So we'll go to Edit Data. I will select all and delete the current data set. The data set that I want to use is one that you may have seen in one of the earlier lab assignments, where we had a sample of children, and each child had a certain number of coins. The first child had 0, the second child had 1, and then 5, 8, 12, and 20. Here we have our original sample with 6 observations. We'll take one bootstrap sample. What this does is it takes a random sample from the original sample with replacement. If we click Show Data Table, we can see that the first randomly selected individual had 8 coins. The second randomly selected individual had 5. That second individual was also the third individual. So after we take this first individual out, we put them back into the sample, so it is possible for the same individual to be selected more than once, which was the case here. These 2 observations in our bootstrap sample are actually the same person in the original sample. Similar to what you saw last week, the bootstrap sample mean is then plotted over here on what is going to become our sampling distribution plot. We can generate one more sample. Here we can see first the individual with 12 coins was selected, an individual with 8, the individual 5, and then that individual was randomly selected 3 more times. This is possible because after every time an individual is selected for the Bootstrap sample, they're put back into the original sample, and they can be selected more than once. This sample mean, 6.667, again, is plotted over here on our dot plot. To speed things up, we'll generate a few thousand Bootstrap samples. Each of the dots on our dot plot represents the mean of a Bootstrap sample. And if you hover over this, actually, the Bootstrap sample plot will change, and you can see each of those 4,000 Bootstrap samples. We're going to use this as our sampling distribution to construct a 95% confidence interval. The information that we need is the mean and the standard error. I'm going to take a screenshot of this, the mean and the standard error, and I'm going to open up Microsoft Word so that I can walk through the calculations with you and you can see them as I'm doing them. So here in Word, I've copied the mean and the standard error from our Bootstrap sampling distribution. Recall, we're going to construct a 95% confidence interval. For a 95% confidence interval, we have the point estimate, which is the mean, plus or minus 2 times the standard error. So we have 7.587 plus or minus 5.656. This gives us a 95% confidence interval of 1.931 to 13.243. To interpret this confidence interval, I could say that I am 95% confident that the population mean is between 1.931 coins and 13.243 coins. This is known as the standard error method. Let's go back to StatKey, and I'll show you how we construct a 95% confidence interval using the percentile method. In the percentile method, we're going to use the same sampling distribution. This time we'll click to tail. The default is a 95% confidence interval. A 95% confidence interval is one that separates the middle 95% of Bootstrap sample means from the outer 5%. By outer 5%, we mean 2.5% on the upper end and 2.5% on the lower end. The bounds of our confidence interval are here at the bottom. So our 95% confidence interval using the percentile method is 2.500 to 13.500. I could say that I am 95% confident that the population mean lies between 2.500 and 13.500. Note that this is similar to the confidence interval that we found using the standard error method. However, it's not exactly the same. One of the reasons why our answers were slightly different with these two methods is that this sampling distribution is not exactly a normal distribution. The standard error method assumes that the sampling distribution is approximately normal. In this case, the distribution is approximately normal, however, it's not exactly normal, so there is going to be some slight variation there due to the shape of the sampling distribution. Next, let's look at an example of constructing a confidence interval for a proportion. We'll go back to the main StatKey page, and we're going to bootstrap a confidence interval for a single proportion. Again, there are a number of built-in data sets, but the example that I'm going to show you, we're going to have a count of 50 out of 100. So maybe we have a random sample of 100 students and 50 were male. Again, we'll generate one bootstrap sample. This uses the same method that we used when we constructed a bootstrap sampling distribution for a mean. Here's our first bootstrap sample. Of the 100 individuals, 45 were male, for a sample proportion of 0.450. Our second bootstrap sample has a sample proportion of 0.580. Again, we'll generate a few thousand bootstrap samples. We can see that our bootstrap sampling distribution is approximately normal, so we can use the standard error method here. In that case, we would take the mean, 0.501, plus or minus 2 times the standard error of 0.050. This would give us a confidence interval of 0.501 plus or minus 0.10, or 0.401 to 0.601. We can also use the percentile method. Again, we'll just check the box for two-tail, and the default is a 95% confidence interval. Here we can see that our 95% confidence interval is 0.410 to 0.600, which is very close to the confidence interval that we computed using the standard error method. Again, our results are going to be slightly different because the standard error method assumes a normal distribution, and we can see we have gaps here. This is not exactly a normal distribution, but our answers are very similar. The last thing I want to show you this week is how you can construct these confidence intervals using the bootstrapping methods in Minitab Express. Here in Minitab Express, I'm first going to show you how you can use bootstrapping methods with a quantitative variable to construct a confidence interval for a population mean. We're going to use the same data that we just used in StatKey concerning the number of coins that a group of children have. We'll go to bootstrapping and bootstrapping for one sample mean. Our sample is coins. The maximum number of resamples in Minitab Express is 1,000, so we'll keep it at 1,000. And we can see the default is a two-sided 95% confidence interval, which is what you're going to want the majority of the time. Here, Minitab Express constructed a bootstrap histogram for coins. This histogram is comparable to the dot plot that you saw in StatKey. Our confidence interval has a lower bound and an upper bound. The green number in the middle is your point estimate. If we scroll down to the bottom, it will also tell us our 95% confidence interval for mu here. To interpret this, I would say that I am 95% confident that the population mean is between 2.667 and 13.333. I'll also walk you through one example of doing this for one sample proportion. For a proportion, you can either have data in your data set or you can enter summarized data. So the example we did in StatKey, we had 50 events out of 100 trials. Again, we want a two-sided 95% confidence interval. The bootstrap histogram that we see here should look very similar to the dot plot that you saw in StatKey. And our 95% confidence interval for this proportion is 0.4000 to 0.6000. In other words, I am 95% confident that the population proportion is between 0.400 and 0.600. The results that you get using this method in Minitab Express should be similar to the results that you get using StatKey. With bootstrapping, however, because it's all based on repeated sampling methods, the results that you get every time are not going to be exactly the same. there is going to be some slight variation in your confidence interval, even if you use the exact same method if you do it multiple times. This is just due to random sampling variation. So when you walk through the examples in the online notes, don't be alarmed if your answers are not exactly the same as the ones in the simulations run through those videos. If you have any questions about whether your answers are close enough to those that you see in the online notes, please post them to the course discussion board so that your instructor can take a look at it and let you know if you're doing something wrong or if the variation that you're seeing is just due to random sampling variation. A few study strategies that you might want to consider this week. I recommend that you identify the parallels between all of these procedures. This week, you're going to be constructing bootstrap sampling distributions in StatKey, and you'll be using both the standard error method and the percentile method. You'll also be constructing confidence intervals in Minitab Express, which uses the percentile method. You should also be able to see the parallels between the confidence intervals for proportions and the confidence intervals for means. The bootstrapping method for both proportions and means is exactly the same. I also recommend that you run through the examples in the online notes yourself. It looks really easy when somebody else is doing it, but then when you go and sit down and try to run through a few on your own, it may not be as easy as it seemed when you watched somebody else do it. So definitely try to run through some of those examples on your own and then check your answers with the videos in the online notes. And finally, if you have any questions, post on the discussion board or attend a Penn State Learning Group tutoring session. These resources are made available to you for free. Please take advantage of them.